Good morning, panelists. Today, let's start off our discussion on styles of reasoning with a very interesting question like have you ever wondered how human beings are different from animals,
I think it is the ability to reason. As Nietzsche rightly said that nothing is precious as human reasoning. And even I strongly believe in the spirit of science which fosters the human reasoning.
Okay, even learning requires the development of not just content knowledge alone, but procedural and epistemic knowledge as well. And what do you guys think about it?
Yes, I certainly agree about content knowledge and procedural knowledge, but I am unsure what exactly that epistemic knowledge means.
Epistemic knowledge is something like how science works.
Do you understand?
Science fundamentally works on empirical evidences. You mean that?
In a way, yeah, but not exactly. What I mean here is that science as a thinking process, science as a different ways of reasoning.
But others, the most pervasive scientific reasoning in science curricula, I find is hypothetical deductive argument, which is popularly known as scientific methods. Do you have anything more to add on?
Yes, of course. We do have 6 different styles of reasoning, such that mathematical deduction, hypothetical reasoning, experimental evaluation, categorization and classification, and probabilistic reasoning, historical and evolutionary reasoning.
Oh, that's great. Despite of having 6 styles of reasoning, focusing on scientific method alone is something like doing disservice to science. And because the idea that a single algorithmic process responsible for the production of scientific knowledge undervalues the very nature and diversity of creative thought, and it's absurd to say a single form of reasoning unifies the science, and
yeah, that's true, but how do we really justify science education must equitably focus on all 6 types of reasoning?
Oh, that's a great question. Anybody want to take it up?
Emphasizing on 6 styles of reasoning leads to the supremacy of scientific methods. But unfortunately, today only 2 styles of reasoning are employed in scientific method. That is hypothetical modeling, and another one is experimental evaluation.
That's true, Sajjan. I do agree with that.
And more importantly, these styles of reasoning are leading to the personalized curriculum, that is personalized way of learning.
That's true as well. And if you see the current trend of teacher education or school education, they are more into personalized learning. So if 6 styles of focusing on 6 styles of reasoning is leading to personalized learning, then we must certainly focus upon promoting all 6 styles of reasoning. Yeah. So now let's delve deeper into each style of reasoning. Yeah.
I would like to start with mathematical deduction. That is the usage of mathematics to solve the problems, that is through reasoning. Mathematics is in general usage of the numerical variables and algebraic constants to solve the physical quantities. That is in a way proving or disproving the generalizations made. That is from unknown to unknown or from unknown to known. That is where the mathematics stands. And today mathematics is an important language of engineering and science itself.
Sajjan, no, it can't be vice versa, but it is like unknown to known.
Yeah, yes.
Unknown, because it is mathematical deduction.
Yeah.
So deduction works on unknown to known. Yeah. Am I correct?
Yes.
Yeah, thank you.
And Sajjan, let me tell you about another style of reasoning as well, which is experimental evaluation, which is the use of empirical investigation and to discover the patterns of nature and also to test the predictions of hypothetical models. Galileo is seen as the key figure who initiated this style to show equal acceleration by dropping 2 cannonballs of different sizes from the Tower of Pisa.
Yeah, Darika, Galileo is a very pioneer of experimental investigation. We all know that, and he has paid his life for standing up on reason. So we all have a great respect for him. Yeah.
Yes.
So, and the next style of reasoning is about hypothetical modeling, right?
Yes.
Okay.
Well, I would like to discuss about hypothetical modeling, which is the construction of the analogical and hypothetical methods to represent the world. I certainly believe that science advances by developing explanatory models. Indeed, this is the primary goal of science. Analogical models are used to represent things which are too large to imagine. For example, as solar system, or things which are too small to imagine, like Bohr's atom or the cell.
Absolutely, Melissa. And these days, if you observe, we have got a lot of simulation platforms like PhET simulation and virtual laboratories, which are primarily working on the development of simulations which are very large to imagine and very small to imagine, like cell organelles and all that. And interactive computer simulations certainly foster different higher order thinking skills like problem solving, decision making skills, and critical thinking as well. And it has got great heft in science education.
I would like to add upon my friend's discussion by adding upon categorization and classification. Like categorization and classification is nothing but the ordering of things. Many scientists solely depend upon the process of classification. For instance, like distinguishing rocks, animals, or particles from each other. We all know the development of periodic table, which depends upon the nature of the elements in the material world. In case of physics, for distinguishing concepts between heat, temperature, mass, weight, and energy and power. If we consider Darwin's work, it mainly depends upon the notion of species which was proposed by Linnaeus. And I think this style of reasoning has a lot of scope in school science education. For an example, if we consider at a school level, considering taxonomic characterizations or metals classification based upon their magnetic properties, there are many examples which we can consider in our daily basis. And now we have discussed what are experimental evaluations and mathematical deductions, hypothetical modeling, and classification also, right?
Yes, Suma. The next one is probabilistic reasoning, which is the statistical analysis and the calculus of probability. For example, the link between skin cancer and sunshine. The link between both of them was established by our data that showed the linear decrease in the incidence of skin cancer per 1,000 members of the population with increasing latitude. That's, as we move towards poles, like moving towards Antarctic or Arctic regions.
I think biology students do a lot of statistical and probabilistic stuff in ecology and some other portions of biology as well. So even probabilistic reasoning has got a lot to do on data analysis, right? It has got a lot of scope in the present trend of education. Yeah. And the last style of reasoning is?
The last style of reasoning is the historical based evolutionary reasoning, that is the construction of historical accounts which attempts to explain the origins of the material world and its features. They are the development of species, the earth, the solar system, the universe, and the elements and more. Darwin's idea emerged based on the variation patterns that exist in nature.
We have discussed about all 6 styles of reasoning, and do anybody got to say something?
Do you know what? Each of these styles of reasoning can be correlated with a legend. For example, Euclid and Pythagoras with Greek mathematics, then Galileo with introduction of explanatory models and hypothetical models, then Linnaeus with classification and categorization. Mendeleev can also be included in that. Then Darwin with evolutionary thinking, and
Poisson
and John Snow with
probabilistic
thinking, like that.
That is very interesting to see, legendary heroes being associated with such 6 styles of reasoning. It's very interesting, Melissa, and we all certainly agree that there is a lot of scope for these 6 styles of reasoning, and these should be incorporated in science education curriculum so as to ensure 360-degree angle development in a student. To sum it up, all these 6 styles of reasoning are good not because they truly detect the truth. Rather, they are good because they are successful. Because of their success, they have become part of our standards to find out the truth. But do you know what? Science is not the absolute truth. Truth is yet to come. I thank everyone for participating in this valuable discussion and sharing your valuable inputs. Thank you one and all. Thank you.
Thank you.